Hello, thank you very much, and then good morning and welcome back. Then my name is Mongkol Ekpanyapong. Then for the past 2 days, you heard a lot about AI, and and then even part of the slide have been presented by Dr. Chakram on the first day. Then I will go over this very quickly about AI history and trend, and then on the other half, I will talk about the research at AI Center, and I also got many requests from some of some of you. Then I can skip. Thank you. Then as Dr. Chakram mentioned, then AI have been here for more than 70 years. Right? It started at the workshop in Dartmouth College in 1956. And then at the beginning, it just do only some toy applications. And then it becomes successful when we start to have the Deep Blue from IBM that win the World Chess Champion, the 2007 DARPA Urban Challenge. And then we have Siri that can do speech recognition. And then we have AlphaGo when the computer can win the Go game over the human. And then in 2022, we have a surprise, the ChatGPT that surprised the whole world. And in 2024, we have the Nobel Prize recipient from the creator, one of the creator of the AI, Jeffrey Hinton in 2024, and John Hopfield. We go very quickly. Some slide has already been discussed. But there are three things that are the major breakthrough in the deep learning or in the AI technology. The first one is the algorithm, the technique. Right? Then the second one and the third one are also some important features like the availability of data. Then for AI, you need a lot of data to be able to do machine learning, to be able to do the deep learning. Also, at the beginning, we don't have this really high performance hardware. This is another requirement that we need for the AIs to be able to get smarter and smarter. Then this one, you can think of AI as a monster. If we give it more data, it will grow, getting smarter, and can do something really smart. If we look back into 1999, the entire world, it have total data storage of only 12.5 terabytes. But nowadays, the volume of data created worldwide increasing tremendously. Then now from 2 zettabytes in 2010, now we are reaching 181 zettabytes, when 1 zettabyte is equal to 1 billion terabytes. Then we create more and more data, and then this one is the food of the AI system. In terms of the computation, we also require a lot more computation. From the first AlexNet model in 2012, it requires about 0.01 petaflop when the flop is floating operation per second. Right? And it keep increasing, then we reaching 1,000 petaflop and so on. Even for ChatGPT, we need more and more flop so that we can do the computation. Okay, then I will skip this. And for the current trend, in the current trend that we know, for the very large model, we need more and more hyperparameter. Currently, it's 2 trillion parameter and keep counting. Also, in 2025, we was surprised by the smaller model like DeepSeek that can do the very similar work, similar to the ChatGPT with less hyperparameter. And also in this year, right, it is the rise of agentic AI. When we hope that it can reach AGI so that it can have the similar performance as human. Then as Dr. Chakram mentioned, agentic AI is just the multiple AI agent that work together so that it can do some smart thing. Yeah, but we will skip on this. Then this one is some prediction that when we could reach the AGI, the generalized system that can think like a human. Then for Sam Altman, then he think that by 2025 to 2029 we can reach the AGI. Elon Musk think that it maybe in 1 or 2 years we can reach the AGI and so on. But for some people think that maybe it will take 5 to 20 years. Right? Then we have to see. But the one key that could reach us to the AGI is the reinforcement learning algorithm that we have mentioned in the first day. Yeah. Then next, I will move to more about our research at the AI Center. Then the AI Center, it was set up in 2018 with the focus to address the local and regional needs by applying AI to transform the research and the development in this area. Right. Then we have the work in smart mobility, smart living, smart healthcare, smart energy, and smart environment. Right. Then if you come from the tollway here, we have implemented what we call smart road system on the tollway across the road near the hotel. Then in this one, we turn the normal camera into the AI CCTV camera. Then we know that accident like this can happen anytime, right? And then if we could use the AI to be the eye of the, instead of human, then it could spot any anomaly, any incident automatically, like the broken vehicle, like the falling object on the road, like the wrong way driving, the motorcycle that's not supposed to be there. Then this one, in the tollway, they have the existing 159 cameras, normal CCTV camera, then we turn it into the AI camera. Then it detects the event like this, the parked vehicle or the broken vehicle, then it pop up the event so that in the control room, the operator can detect it, and then the AI system can detect it, and it will pop up so that it alert the officer. So that in the past it takes them about half an hour to notice this kind of event, but nowadays it takes only 1 or 2 minutes. Yeah. Then it show up on the screen, and then the operator can support those, can dispatch the team to help support those. We also collect the statistic information like the traffic information, the number of vehicle, the vehicle speed, and vehicle type, so that they can use it for data collection. Then we also test the system day and night, and currently the system is operating 24 hours. And then this one is the real event when there is the broken bus, right? And then the system detect and alert to the officer. Then this one is the wrong way driving, that it should not supposed to be there, but this one is for maintenance. The human on the tollway, that also not supposed to be there, and the system alert and tell the officer, the motorbike, that not supposed to be there. This one, they test the system by putting some objects to detect whether the system can detect or not. Yeah. We also work with BMA, Bangkok Metropolitan Administration, so that we can collect the traffic information. In the past, they have to send a human every 6 months to do the survey, so that they know for each junction how many vehicles are there. Then in this one, we turn the current CCTV camera to collect the traffic status, the queue length, the turning ratio, whether how many vehicles turn left, going straight, or turn right. Then this one we work with the Royal Police Department to detect the traffic violation like no helmet wearing, red light violations, speeding, wrong way driving, and then lane change violation. So that if we detect any illegal move, illegal driving, then we send the information including the image, the license plate information, the small video clip. Right. Then this one is the before and after violation, the license plate information, and then the small video clip. And then the police can use this to issue the tickets. Then this one shows the example of the ticket. In Thailand, we have a lot of problem for the motorbike that do not wearing the helmet. Okay. Then this one, we install the system in Phuket when we detect any automatic accident automatically, like this case, when it's slippery, and then AI could detect and inform it to the officer. This system, we call it multi-camera tracking. If you come to Bangkok often, we have the area called Ratchaprasong. When it is about 9 stations from here, it is the very crowded area and have a lot of tourists. In this one, we use the AI camera to detect the human appearance, the tourist appearance, like the clothes, the shirt color, the pants, whether they wear the hat, they have the bag, and so on. And then we track over multiple cameras so that we know whether this person moved from the first camera to the second camera, where and the direction. Yeah, then this one show multiple camera. In that area, we have about 100 cameras. And then let's say it can track the person. If there is the thief, some suspect case, the police could know whether what is the first scene that we saw this person, the second scene, and so on. In the past, the police have to track back the recorder to check, and that take weeks. Right? This one, it will be almost or near real time. We take like 1 or 2 minutes so that it can track the person. Then this one show the example. If we want to track the man in the yellow shirt, yellow T-shirt, then we just run the system. We just click, and then the system will show the location on the map. From the first location that he come to this area to the last location that we saw him. Then by click at the spot, it show the image of that person and track along the way. Yeah. Yeah, so that it could help the police to track the suspect. And this one we show the images of that person from the different cameras. Okay, this one is the license plate. We're working with stolen stolen vehicle division of the police. Then basically we install the AI on the police camera so that it can track. Yeah. Let me see. It reads the license plate, and we also install the system on the police vehicle. Let me show this one. Okay. Then, then once the police drive the vehicle, they can track the vehicle that was on the blacklist, so that we know that this one is stolen vehicle or not, right? And then send the system to alert. Or they can use the mobile phone to take the photo and then check whether this one is in the stolen vehicle list or not. Then this one we work with the Mahidol University. Then we make the AI system that detect for the elderly people, so that if they are alone and then they fall down, the system will detect it automatically. Like this case, it will alert that it fall, and it will alert to the caretaker. We also collect the statistic information, like the activity of the elder people, so that if he or she have less activity, then the hospital will send the people to visit the elder. Then this one is the work with the Sirirat Hospital. Sirirat is the one of the largest hospital in Bangkok. And then we use the AI to detect from ultrasound image to detect the tumor. Then when we get the tumor, then we send the alert to the radiologist, so that basically it can help radiologists at the second opinions. Then this one is also the work with Sirirat Hospital. Then we use the MRI images. We collect the MRI images and use the AI to classify the MRI to be three cases. The normal case, the MCI stands for mild cognitive impairment. And then the last one is the Alzheimer case. Then we want to do the early MCI detection, so that during the MCI, the radiologist still have the way to prolong the disease. But once it becomes Alzheimer, there is no cure. Then in this one, we try to use the AI system to detect the MCI from MRI images. This one shows the example of the MRI images, right? And then the AI prediction score. We also work with the Mongkol Hospital to use the AI to take the picture from microscope to detect the leukemia disease. Right? We work with the Provincial Electricity Authority of Thailand to use the AI to predict the power that we will get from hydro generator. The power that we get from solar panels, they have 2 megawatt solar panel, they have 2 megawatt solar, hydro generator. And then from the prediction, we use AI to decide whether when to charge the battery, when to use that power to supply the village. Right. Okay, then we skip this one. We get about 88% correlation for the power generator prediction, and then about 96% correlation for the power demand prediction. We also predict whether when we will have power failure. Then this one we work with the MWA, it Metropolitan Water Authority of Thailand. Then in the past, they have to have the human to make sure the width and the depth of the trench, right? Then we use the AI system so that this can be done automatically. We have AI system to monitor the water level in the canal, so that if it reach some level, we alert to the nearby officer. Then this one, if you come to Thailand during the January or February, you will see a lot of PM2.5. And then there are three main sources of PM2.5. One is open burning. Second one is the traffic. And then the third one is the from industry. Then when we collect those data and then use the weather forecast model to predict the concentration of the emission of the PM2.5. Then we use our camera that already installed to collect the statistic of the traffic, right? From the traffic. And depending on vehicle type, we can calculate the amount of PM2.5 for each vehicle type. And this one, when the vehicle come to the CCTV, then this one, it compute the PM2.5 amount released by each vehicle. We also use the satellite and then AI to predict what is the crop type. Usually for open burning, they burn the crop, the remaining of the crop, so that they can start the new cycle. And then we use the AI to predict, when we see the burning spot from satellite, we predict what is the crop type in that area, so that we use it to predict the PM2.5 emission. Then we do it in many countries, in Vietnam, in Myanmar, in Thailand, in Cambodia, in Laos. Right? And then from that, we use it to predict the amount of PM2.5. We also have camera to install on the mountain, so that if we detect the fire or smoke, then we alert to the officer so that they can go and stop the fire. And then the last one we just use the API system to collect the SEM. SEM is the emission measurement at the factory plant, so that we use this information to compute in our system so that we can compute all the PM2.5, and then we can do the prediction whether, let's say, if we get the smoke, if we get the PM2.5, where are the source of the PM2.5, like it comes from this area, and so on. Then this one, we put it in our model. In Bangkok, during that time, when there are a lot of PM2.5, the BMA plan to stop vehicle to come into Bangkok area if they have a lot of black smoke. Then we use AI system to detect black smoke and compute the PM2.5 level, and then send to the officer, so that we read the license plate and do not allow this vehicle to come into the Bangkok area. Then here show the example from the using normal CCTV. If the vehicle come and emit the black smoke, then the system detect and alert. In this case, we can install it on the vehicle, and when we see another vehicle that emit a lot of black smoke, then we detect and alert. This one is the one with the GIC. GIC is another unit in Site AT. Then we try to detect the trash on the road, as well as compute the amount of the trash, so that we can inform the officer that this area have a lot of trash, and then they should come and do the service. We use the AI to calculate the volume. And this one compare with the hardware device that can also compute the volume. And then this one just using camera. And then the last work, we work with the T company to use the IoT system equipped with the audio microphone, so that we can detect the bird sound and the insect sound. And from that sound, we try to classify and use that to compute biodiversity score from 1 to 5. Right? If it's 5, then it high biodiversity like the forest. If it's 1, it is the low biodiversity score. Then currently, these are the birds that we can use AI system to classify. And then these are the insects that we can use. These are the example of the insect and example of the bird that we can use AI system to classify. And then here are some of the work at AI Center. Yeah. Thank you very much. Yeah.
Thank you very much. Now we open the floor for Q&A. So are there any questions?
Thank you, Dr. Mongkol, for the insightful presentation. I want to ask about smart road. When we came from the Swarnabhumi to here, we passed to the toll road, and there is a gate, but it's when the car past the gate is automatically open. So can you share to us about the smart road, how they detect for example, the license plate, and how do you overcome? You said that that is the normal camera, but it become a AI camera. Right? How do you manage the accuracy of the license reading, and is when the car go to the gate and it's open, the car is pay something or it's free?
Oh.
And how it's managed when for example, the credit is 0 or something. Mm-hmm. Is it closed or
then
open?
Then in the tollway, then there are 2 systems. One system they use the RFID. That one it don't use AI. It just RFID, and one they detect the RFID, they charge on the account. Right? But there is also another system, but it's not our system. They look at the license plate, and then once they pass that area, then they will read the license plate and check whether it registered or not. If it registered, then they will deduct from that account. If it not, then we have to pay the fee, the toll fee within 24 hours, if I remember correctly.
Oh, okay.
But to turn the normal CCTV camera, then we need a computer to connect to those CCTV, and then to make it more accurate, we need more and more data, as I mentioned earlier. Then we have to train more and more, so that the system getting smarter and smarter.
Okay, thank you.
Thank you so much for this real and practical application of machine computer vision system. I just wanted to know, like, how the data from the site are collected. I mean, is there like fiber optics, or what is the medium like? Is there 5G or for the near real-time monitoring? How you are collecting those data, and how is the processing? I just wanted to know.
Then it depends on case by case. Like the smart road that we have, that one they install the fiber optics. And then the fiber optic installation is really, really expensive.
Yes.
Much more expensive than AI system. Then this one they use the fiber optic along for the entire road. I think it's about 30 kilometers on the road. But for some cases like this one, like the biodiversity scoring, this one we deploy the system in Chiang Mai. This one in Chiang Mai, and there are forest area. Then they just use the 5G to send the data back. Then with 5G, then we have a lot of communication issues. Sometimes the system go down and so on. Yeah. Fiber
So-
optic is more reliable. Yeah.
So it is video, right?
No, this one is audio.
Audio, okay.
But we have the case that we deploy the system using 5G on CCTV too. But that one we have to do processing at the edge and only send the metadata or the computed data back. Right?
Thank you. Thank you, sir.
Are there any more questions? Or those participants who are online, you can also unmute yourself and or type in the chat. Okay.
Appreciate all the the project that had been presented. My curiosity is related to whether the data, because it's the system, life system, and life system is always collecting the data. Do you also provide data sets that can be useful for future research? For example, those events happening in the tollway, those data sensors from the forest and everything.
Then it depends on the project. Right? For example, the smart road, we was hired by a private company. Then that data we cannot share. But let's say for this project, the elder care people, elder care detection. This one is funded by government. Then we are submitting a conference paper, and then if it get accepted, we plan to share that data set, but not the real event, because we have PDPA issue, but the event that we collect the data by our students and so on, then that one we can share. Yeah. Let's say for this case, this one is the actual falling that the AI system could detect, but we replace it with the cartoon so that we do not violate PDPA. But this one, it have PDPA issue. Yeah.
Data
For
like
the
publics like Kaggle or Zeno.
for the conference paper, once it get accepted, but yeah, it simulated data because we use our student to try to form. Then for example, in this research, we have to ask master student, PhD student to try to fall down many times, many angles, so that we can collect those data.
When you've done this test, right? So with like taking care of the elderly people, how many times did you have this false alarm? Like the AI system not being able to report properly, and in those cases, how did you do that reiteration on those systems?
Then if you train the AI system, you will know that there are false positive, right, for alarm, and then false negative. Then you miss the detection, right? Then it depends whether how do we tune the system. If we want less false negative or less miss, then it could increase the false alarm, yeah, and then it is a trade-off. But at the end, once you have more and more data, your system will be more accurate. Yeah.
I was just curious if there were any false alarm during your test.
There are always false alarm. Yeah. but it depends. For example, depend on application. For example, if it elderly people, we don't want to miss, then we may accept some false alarm, but we want to make sure that if the elder people fall down, we don't miss. On the other hand, let's say for the police case, the law enforcement, we don't want to issue the ticket to the wrong person, because that will be a lot of headache later on. Yeah.
For the interest of time, so we will take one more last questions if the participant have any. Seems like there's no more questions. Thank you so much, Dr. Mongkol, for your sharing and perspective of all the projects that AI Center is doing. Thank you very much.